This is the mind map for oxidation and reduction chapter, or the redox chapter. Now the first thing that we need to look at is the definitions for oxidation and reduction. Now oxidation and reduction are opposite of each other. And for oxidation there are 4 definitions. For reduction there will be another 4 definitions, and they are just opposite of each other. Now the first definition of oxidation is the gain of oxygen. The second definition for oxidation is a loss of hydrogen. The third definition of oxidation is the loss of electron, and the fourth definition for oxidation is the increase in oxidation state. Now the first one is the gain of oxygen. So substance to be oxidized must gain oxygen. Now what do you mean by that? Let's look at the first example here. Calcium reacts with oxygen and calcium oxide is produced. So the calcium here, before the reaction takes place, there is no oxygen in the calcium here, and then after the chemical reaction, calcium becomes calcium oxide. So calcium is oxidized because it gains oxygen to form calcium oxide. So in this chemical reaction, calcium is said to be oxidized, or calcium undergoes oxidation. Why? Because it gains oxygen to form calcium oxide. The second example, zinc and copper oxide to form zinc oxide and copper. So in this example, copper oxide is reduced. Why? Because there is a loss of oxygen. So initially is copper oxide CuO. There is an oxygen here. After the chemical reaction, CuO becomes Cu. So there is a loss of oxygen. So gain of oxygen means oxidation. Okay, gain of oxygen means oxidation. So loss of oxygen, which happened to copper oxide, would be reduction, because oxidation and reduction are opposite of each other. Okay, loss of oxygen is actually reduction. Now let's look at hydrogen. Loss of hydrogen means oxidation. Okay, oxidation, loss of hydrogen. An example, this chemical reaction, hydrogen and chlorine react to form hydrogen chloride. Now this HCl is not hydrochloric acid. Hydrochloric acid must be HCl and then aqueous, AQ. Okay, that one is hydrochloric acid. HCl gas is actually hydrogen chloride gas. So this part you have to take note of. Now chlorine is said to be reduced to HCl because chlorine, to become HCl, there is a gain of hydrogen. So gain of hydrogen means reduction. Therefore over here is reduced. Let's look at electron. So loss of electron means oxidation. Okay, oxidation, loss of electron. Let's look at this example here. Iron 3 chloride, this is actually iron 3 chloride become hydrogen sulfide. Now iron 3 chloride react with hydrogen sulfide, becomes iron 2 chloride, hydrochloric acid and sulfur. Now iron 3 ions, now you have to take note that this iron 3 ions is actually this one, Fe. Now this Fe is not iron, it is iron 3 ion. Okay, if you look at FeCl3, it is actually an ionic compound because metal and non-metal, metal and non-metal combined together, that is called ionic compound. Now ionic compound from the word ion. Ion means there is positive ion and negative ion combined together. So this FeCl3, you can actually split it up into Fe and Cl. Now Cl, you know that chlorine is group 7. Group 7, all the group 7 elements form negative ion, and the charge should be 1 negative, and there are 3 of them, so 3 negative. So 3 negative, this part is 3 negative, so this part must be 3 plus. So this one is actually your iron 3 ion, Fe3 plus. So you cannot say iron. This is not iron, this is iron 3 ion. Now let's look at this one. Iron 3 ion are reduced to iron 2 ion. This is iron 2 ion. So iron 3 becomes iron 2. Now why is this iron 2? Same thing, FeCl2. It is an ionic compound, so you can actually split it up into Fe and Cl. And Cl, you know already, group 7, so the charge is 1 minus. There are 2 Cl here, so the total charge here is 2 minus. So this one must be 2 plus in order to balance the charge, because for the whole compound the charge is neutral. So this is your iron 2 ion. So iron 3 ion change to iron 2 ion. Fe3 plus change to Fe2 plus. Now Fe3 plus change to Fe2 plus, is it a gain of electron or a loss of electron? Now in order to find out, because loss of electron means oxidation. Loss of electron means, okay, loss of electron means oxidation. We don't know, so we need to find out Fe3 plus become Fe2 plus, is it a loss or gain of electron? If it is loss of electron, then it is oxidized. If it is gain of electron, then it is reduced. So in order to find out whether it's oxidized or reduced, we have to look at Fe3 plus to Fe2 plus, whether it's gain or loss of electron. So how do we find out whether it's a gain or loss of electron? What you can do is you just assume a certain number of proton. Let's say if your lucky number is 10, so you assume that iron 3 plus has 10 proton. Iron 2 plus will also have 10 proton, because they are the same substance. Same substance must have the same number of proton. Now let's look at Fe3 plus. Proton is positively charged, electron is negatively charged. So the net charge here is 3 plus. Net charge here is 3 plus means that the number of proton is 3 more than the number of electron. So the number of electron must be 7 electron. Okay, because this is proton is positively charged, so 10 proton means 10 plus. But over here the net charge is 3 plus, so there must be 7 minus charge, 7 negative charge. Okay, 7 plus, 10 plus here, sorry, 10 plus here, and then there must be 7 negative charge, because 10 plus 7 minus, you get 3 plus. Okay, this is minus, so 10 plus and 7 minus, you get 3 plus. So there must be 7 electron here. How about Fe2 plus? Fe2 plus, there must be 8 electron here. 10 plus 8 minus, you get 2 plus. Okay, now 7 electron to 8 electron, there must be gain of 1 electron, correct? Gain of 1 electron. So therefore, in order for Fe3 plus to become Fe2 plus, you must gain 1 electron. Gain of electron, okay, according to the definition, gain of electron is reduction. Therefore, the answer here is reduced. Okay, iron 3 ions are reduced to iron 2 ion. Alright, let's look at the next example. Copper react with silver nitrate. This is actually silver nitrate to form copper 2 nitrate and silver. Now let's look at copper. Copper is Cu, so copper becomes this is not copper. This is actually copper 2 ions. Now let's look at this question. Copper become this one, copper 2 nitrate. This one again is an ionic compound. You can split it into copper and nitrate. Nitrate, this is one of the polyatomic ion which you need to remember the formula. It is NO3 negative. There are two of them. So the total charge on this side will be 2 negative. 2 negative, this side must be 2 plus in order to balance the charge. Because the whole thing, the charge is 0. So this is actually copper 2 plus. So copper to become copper 2 plus, is it gain of electron or loss of electron? So copper to copper 2 plus, is it gain or loss of electron? Same thing, you assume a certain number of proton for copper. Let's assume that copper has 8 electron. You just assume it, just take any number you want. So if copper atom has 8 proton, copper ion, copper 2 ion will also have 8 proton, because both are copper. Same substance have the same number of proton. Then if it has 8 proton, this one should have 8 electron as well. Why? Because the charge here is 0. That means the copper is actually, this copper is actually neutral. Neutral means that the number of positive charge from the proton is should be the same with the number of negative charge from the electron. Now how about here? 8 proton. How many electron do I need to have in order to have copper 2 plus? I need to have 6 electron. Why? Because 8 plus 6 minus, I'll get 2 plus. CO2 plus means that the number of proton must be 2 more than the number of electron. And the same thing, 8 electron to 6 electron, is it gain or loss of electron? It is a loss of electron. So loss of electron, according to the definition, loss of electron, it is oxidation. Therefore copper is oxidized to copper 2 plus. Okay, this part is the loss of electron. Let's look at the last definition of oxidation and reduction, which is oxidation state. So if I have an increase in oxidation state, that is called oxidation. Now let's look at this. Now first of all, oxidation state is very similar to the charge of a compound or of an element. Oxidation state actually is very similar to the charge. So if you want to calculate oxidation state, you look at the charge of the substance. Over here, now this table will teach you how to find the oxidation state. Now oxidation state of free element is 0. Like for example copper. Copper is just Cu by itself. What is the charge? The charge is usually at the top right corner, right? So Cu, the top right corner, there is no charge. Therefore the oxidation state is 0. Same thing with Cl2, there is no charge here, 0. So whenever you see a substance, there is no charge to it, then the oxidation state is 0. So no charge means oxidation state is 0. Now the next one is oxidation state of ions. It's the same with the charge of the ion. So same thing, if I have a potassium ion, so the charge is actually 1 plus. Oxidation state will be +1. So is the opposite. So if I have charge 1 plus, the oxidation state is +1. Likewise for oxide ion, O2 minus is oxide ion. The charge is 2 minus, so the oxidation state is -2. Let's look at the next one. Total oxidation state of all atoms in a compound is 0. So if I have CaCO3 like this, the total oxidation state for the Ca, for the C, for the O3, the total oxidation state should be 0. Okay, and then each one of them you can find out the oxidation state. For example, calcium. So if you want to find out the oxidation state of calcium in CaCO3, that would be the same with the charge of the calcium. So calcium is in group 2, which means that it forms Cu2 plus. So the charge is plus 2. Okay, likewise for the rest. And total oxidation state of all atoms in the polyatomic ion is the same with the charge of the ion. So SO, this is a sulfate ion, SO4, 2 negative. So the total oxidation state for this sulfate ion would be -2, because the total oxidation state would be the same with the charge, and the charge for a sulfate ion is 2 minus, therefore the oxidation state is -2. Now let's look at the example. Let's look at the example here. Now over here, zinc, this is actually an ionic equation. Zinc plus copper 2 plus, you get zinc 2 plus plus copper. So copper 2 ions, which is Cu2 plus, copper 2 ions are reduced to copper. Now copper 2 ion is Cu2 plus to copper. So you have to look at the oxidation state. Okay, in this method you have to look at the oxidation state. So what is the oxidation state for copper 2 plus? Remember, the oxidation state of a substance is the same with the charge of the substance, just that the sign is reversed. Instead of 2 plus, the oxidation state is +2. How about the oxidation state for copper? Same thing. The oxidation state of copper would be the same with the charge of the copper. This is copper atom. It's not copper ion. It's not copper 2 ion. This is copper atom. Is there a charge for this copper atom? Is there a charge here? There is no charge. Therefore, the oxidation state is 0. So from +2 to become 0, is it an increase or decrease in oxidation state? +2 to 0 is actually a decrease, right? So +2 to 0 is a decrease in oxidation state. Decrease in oxidation state is reduction. Therefore, the answer here is reduced. Okay, copper 2 ions are reduced to copper. Now let's look at zinc. Zinc would be oxidized to zinc 2 plus, because zinc to zinc 2 plus, what is the oxidation state for zinc? It's the same with the charge of the ion. It's the same with the charge of the substance. There is no charge here, so oxidation state is 0. How about Zn2 plus? What is the oxidation state? Oxidation state is the same with the charge of this substance, and the charge is 2 plus, therefore oxidation state is +2. So there is an increase. This one, there is an increase. 0 to +2, there is an increase, right? So increase in oxidation state, increase in oxidation state is actually an oxidation process. Therefore, zinc is oxidized to Zn2 plus. Let's look at the next example. Okay, this example, now this is bromide ion Br minus. The minus should be at the top here. So Br minus, change to Br2. So Br minus to Br2. So Br minus, what is the oxidation state? It's the same with the charge, which is -1. Br2, what is the oxidation state? It's the same with the charge. There is no charge, therefore the oxidation state is 0. So -1 to 0 is an increase. -1 to 0 is an increase. Increase in oxidation state is oxidized. Likewise for chlorine atoms. Chlorine atoms is Cl to Cl minus. Cl, the oxidation state is 0 because there is no charge. Cl minus, the oxidation state is 1 minus. Therefore, the oxidation state is -1. So 0 to -1 is an increase in oxidation. It's a reduction. -1 is less than 0, right? So 0 to -1 is actually a reduction or a decrease in oxidation state. Decrease in oxidation state is a reduction process. Therefore, it is reduced. So there are many ways. There are 4 ways basically to look at whether a substance is oxidized or reduced. Certain questions you can use more than one method to look at it, whether it's oxidized or reduced. Alright, so these are the 4 definitions that you need to get yourself familiar with.